12 satellites have just taken off in China, but these aren't ordinary machines. Together, they mark the beginning of the world's first orbital supercomputer, a network designed to think, process, and share data in space. Instead of sending information back to Earth, each satellite carries its own powerful AI brain, crunching data instantly and linking up through high-speed laser connections. This breakthrough could transform everything from disaster response to space science. What China has built with the first 12 satellites is essentially a foundation for the world's first orbital supercomputer. Instead of operating like traditional satellites that mostly collect information and beam it down to Earth for processing, these new units are designed to think for themselves. Each carries an artificial intelligence model with around 8 billion parameters, a scale similar to models that usually require entire data centers on the ground. These models give each satellite a processing ability of roughly 744 tera-operations per second, also known as TOPS. When you multiply that performance across the initial group of 12, the result is around 5 peta-operations per second, POPs, in total. That is already comparable to some supercomputers on Earth, and it is only the beginning. The long-term plan is ambitious. A full constellation of 2,800 satellites working together to achieve 1,000 POPs. If reached, that would put the system in the same league as the fastest machines ever built on Earth. But the power of this project lies not just in the raw numbers. These satellites are connected by high-speed laser links, capable of sharing around 30 terabytes of data among themselves every day. Instead of being bottlenecked by limited ground station time, the satellites form their own network in space. They also carry scientific payloads that go beyond computing. Instruments like an X-ray detector for cosmic events, or sensors that create 3D digital twins of Earth's environment, make these satellites useful for both science and practical applications. By processing the data on board, they can generate insights on natural disasters, atmospheric changes, or cosmic bursts almost instantly. The importance of this new constellation is best understood by looking at the bottlenecks of current satellite operations. Most satellites today send raw data back to Earth, but due to bandwidth and limited ground station windows, only a small portion of what is collected is ever analyzed. Experts estimate that less than 10% of satellite data actually makes it to Earth in usable form. That means much of what satellites see in orbit never contributes to decisions, research, or real-world problem-solving. With onboard AI processing, this changes dramatically. Instead of waiting for ground stations, these satellites can process and interpret their data in real time. One of the most obvious benefits is speed in responding to urgent events. Natural disasters such as floods, wildfires, or earthquakes require instant awareness. If satellites can detect, process, and share information about these events without delays, response planning becomes far more effective. The same logic applies to monitoring global environmental trends like deforestation, ice melt, or pollution patterns. By making decisions in orbit, data is delivered much faster and with far less loss. Another reason this matters is efficiency and sustainability. Operating advanced computing systems on Earth requires enormous amounts of energy, especially for cooling. In space, the satellites draw continuous solar power and naturally radiate heat into the vacuum of space. This reduces the energy footprint compared to massive terrestrial data centers. The result is not just faster computing, but greener computing as well. Finally, this matters because it signals a new direction in space technology. Satellites are no longer just eyes in the sky. They are becoming brains too. The ability to process data in orbit means Earth observation, scientific exploration, and even commercial applications like virtual tourism will move into a new phase. The launch of these first 12 satellites is not just about China. It raises questions and lessons for the entire world. The most striking lesson is that computing is shifting locations. For decades, data processing has been rooted on Earth, but now we are watching the start of a move into space. If the project scales to its planned 2,800 satellites and reaches 1,000 POPs, then the balance of how we use satellites, AI, and data could change forever. Space would no longer be just a source of data, but also a platform for decision-making. Another key takeaway is the importance of scale and integration. A single powerful satellite cannot provide the benefits of an interconnected constellation. What makes this system so special is the combination of advanced onboard AI, laser communication links, scientific payloads, and the sheer number of satellites planned. It is this synergy that creates something greater than the sum of its parts. Other nations or organizations aiming to follow will need to replicate not just one aspect, but the entire system of technologies working together. There are also broader implications for international competition and cooperation. The European Union and the United States have already shown interest in orbital data centers, and this move may accelerate their efforts. It could inspire new partnerships, or in some cases, parallel projects designed to ensure no region falls behind. For the general public, one lesson is clear. The information we rely on daily, from navigation to weather forecasting to emergency alerts, could soon be shaped by satellites that think and act in orbit. That means faster updates, richer data, and potentially new services that we have not yet imagined. It also raises questions about governance, orbital congestion, and ethical use of AI in space. What we're witnessing is more than just another satellite launch. It's the start of a new era where computing leaves the ground and begins operating in space itself. These 12 satellites are only the first step toward a constellation that could rival the most powerful systems on Earth, all while powered by the sun and cooled by the cosmos. It's a reminder that the future of data, science, and technology may orbit right above our heads. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Thank you for watching, and see you next time.